Hello, my name is Mr. Asprey, and this is number 50, sectors. If you're watching this in 2025, then check out my IGCSE Grade 9 live revision session that I'm going to be doing in the Easter holidays. Link in the description. Okay, sectors. Essentially, all we need to know for sectors is the area of a circle is pi r squared, and the circumference of a circle is 2 pi r. Now, if you are trying to work out the area of a sector, then it is a fraction of the circle. And the fraction depends on how much angle we have, in this case 50, but in more general, we call it theta, out of all the angles you have in the circle, which is 360. And again, for the circumference, if you're looking for a part of the circumference, let's call it the arc length, is what it's called, then we multiply this whole circumference by the fraction, which is the angle out of all the angle in the circle, which is 360. So you've got these two formulas, you're good to go. So let's use them. It says work out the length of the arc of the sector. Okay, so we're going to use arc length. And as I've just alluded to, it's equal to the angle over 360 multiplied by the circumference, which is 2 pi r. So in this case, the angle is 50 out of 360 in a circle, times by 2, times by pi, times by r, which is 7. So that just goes into our calculator. So I've put it in just like that, and then press equals, and it gives me that, and I press this button here, and that converts it into a decimal, and it says to one decimal place, so we have 6.1. Job done. Okay, next question, we are looking at the area of the sector, so we're going to do the angle over 360 multiplied by the area, which is pi times by r squared. And this will give us the area of the sector. So the angle is 110 out of 360 multiplied by pi times by the radius, which is 7.1, and then we have to square that, and then we just put that in our calculator. Okay, so there we go, in it goes, press equals, press the button to turn it into decimal, and that is 48.4 rounded to one decimal place. Perfect. Job done. Okay, next question, and it's asking us a slightly different question. It says the perimeter of the sector, so we've got to be a bit careful. But the first thing we're going to find is the arc length using our formula, because that is a fraction of the circumference. In fact, it is 67 out of 360 of the overall circumference, which is 2 pi r, and r is 5.2. So I'll put that in my calculator, and I get this. I'll then convert that to a decimal, so that's 6.08. And then in order to work out the perimeter, we have to go all the way around the shape. So I need this side, which is a radius, and I need this side, which is also a radius as well. So I can write here the total perimeter is going to be the arc length plus 5.2 plus another 5.2. So I go back to my calculator and I just plus 5.2 plus 5.2, and that gives me a final answer of 16.5 to 3 significant figures. Bosh. Okay, next question. It again says calculate the perimeter of the shaded area. Now what we have is we have the minor sector here being 40 degrees, but the bit we want is the shaded area, which is called the major sector, basically because it's just the bigger side of it. If that is 40 degrees there, then it means this must be 360 minus 40, so that must be 320, that angle there. Okay, so if I want to work out the arc length of this major sector, then I'm just going to have to do, as we've done before, the arc length is equal to the angle of that sector out of 360 multiplied by 2 pi times by the radius, which is 9. So I can get that answer from my calculator. And this gives me 16 pi. Perfect. So I'll just convert that into a decimal. 50.3. And then once again, we're looking for the perimeter. So I'm going to have to also include this distance here, which is a radius, and this distance here, which is also a radius. So the perimeter is 50.3 plus a 9 plus another 9. So I just simply go plus 9 equals, and I get my final answer of 68.3. Bosh. Okay, more interesting question here. We're told the area, so we need to work backwards in order to work out the angle, and then that will allow us to use the angle to work out the perimeter of the sector. So the area formula is the angle over 360 multiplied by pi times r squared. And we know that the area is going to equal 40. So we've got theta over 360 times by pi times by the radius, which is 7 squared, is equal to 40. So if I want to work backwards, I really would like to know what theta over 360 is. So I'm going to have to divide both sides of this equation by pi and by 47 squared. So that gives me 40 over pi times 47. So I've just divided both sides by pi times 47. And this is going to give me an answer for theta over 360. Okay, so that's going to be 40 over pi, pi times by 7 squared. Okay, so that's going to give me 0.2598, and then we can times through by 360, and that will give us the theta value of 93.5. Okay, good. So we've just rearranged that equation by dividing and timesing to get our theta value. Now we've got that, we can work out the perimeter by first finding the arc length. So that arc length there, as I've said before, is going to be the angle, which we know, over 360 times by 2 pi r, which is 7, because 2 pi r is the circumference, and we're working out a fraction of the circumference. So I'll divide this by 360, and then I'll times it by 2, and I'll times it by pi, and I'll times it by r, which is 7. Okay, it gives me 11.4. So that's the arc, that's the yellow part of the shape. And now, because we're asked for the perimeter, we're going to need this and we're going to need this, both of which are 7. So we can say the perimeter is equal to 11.4 plus 7 plus 7. So I take my previous answer and I just plus 7, and I get an answer of the perimeter is equal to 25.4, and that'll be in centimetres. And we'll underline this and we'll give it a tick, and that is job done. Okay, next one is asked us to work out the area of the circle. Okay, we've got this angle here, and we've also got the arc length, which is 5. So we know this distance in here is 5. So we're going to work backwards. We're going to work backwards to find the radius this time, because we don't know what the radius is. So using the green bit of information, the arc length, we know that the arc length is equal to the angle, 55, over 360, multiplied by 2 times pi times r, which we don't know. But we do know the arc length is equal to 5, because it says it right here. Okay, so we need to rearrange this equation now to find r. So the first thing I will do is, what's the most efficient way of doing this. Let's multiply both sides by 360. Let's do it that way. So the right hand side becomes 5 times 360. And then the left hand side, we will just cancel this divide by 360, which is absolutely fine to do because all of these terms are times together. So dividing by 360 affects all of them, and we times by 360 to cancel. So we get this side will be equal to this. And then the left side will be, well, all those yellow things times together. So 55 times 2 times pi, which is, let's just leave it like that, 110 pi. So it's 110 pi and then times by r. So now to find r, we just need to divide through by that 110 pi. Like so. So we do 1800 divided by 110 pi, and that gives us 5.209. Okay, now we need to find the area, so we're just going to use the area formula. Now we've got all the information. The area is the angle. Oh, careful. It says work out the area of the circle, not the sector. So the area, of course, is just pi r squared of the circle. So it's just pi multiplied by 5.209 squared. So we just simply square this answer, times it by pi, and we get 85.2, and that will be centimeters squared. Bosh. Okay, right, on to the first super tricky question, and we have a sector of a circle and the radius is r plus 7. The angle's 45. The circle has a circle C, a different circle, has a radius of this, okay? And then the area of the sector S is twice the area of the circle. So I always have to write this out. So the area of the sector S means equals, twice means 2 times the area of the circle C. So we know that S is equal to 2 times C. Find the value of R. Okay, well let's work out the areas of both of them. So the area of the sector S is going to be 45 over 360 times by the area of the circle, which is pi, times by the radius squared. And we're told that's equal to 2 times C, and C is the area of a circle, so there's no need for an angle because it's the whole circle. So it's just pi times by the radius squared. Okay, so there's our equation. Now all we've got to do is just solve it. So the first thing I'm going to do is divide through by pi, because both sides are multiplied through by pi, so pi is a factor we can divide through. I'm then going to times through by 360. So so that will give us this, plus times by this bracket, and then 2 times 360 is 720. So it'll be 720 on this side, times through by this bracket. Okay, now again I want to try and keep my numbers down, so can I divide both sides by 45? Does 720 divide by 45? Yes it does, perfect. So let's divide both sides by 45. So I just have r plus 7 squared is equal to 16 lots of r minus 2 squared. Okay, so I can't do any more simplifying now, so now's the time for me to expand. So this double bracket, r plus 7 times r plus 7 will give us r squared. It will give us 7r and another 7r, so 14r, and then finally it will give us 49. And this double bracket, r minus 2, r minus 2, will give us r squared. It will give us a minus 2r and another minus 2r, so minus 4r, and it will give us positive 4. Okay, now we're going to have to times that all through by 16 on the right hand side to get 16r squared minus 64r plus 64. And then we're going to subtract r squared from both sides. That will leave me with 15r squared over there. We'll subtract 14r from both sides, which will leave me with minus 78r. And we'll subtract 49 from both sides, which will leave us with 15. Yes, just checking my mental maths is right. And that leaves 0 on the left side, and that is exactly how you want a quadratic. You want it equal to 0, so then you can factorize. Okay, or use the quadratic formula. Now, because it's equal to 0, I can divide this whole equation through by 3, because I've spotted a factor. So again, keep our numbers down is useful. 26 and plus 5. Okay, now how do I factorize quadratics? Well, I do it in a slightly funky way. What I do is I take the a and the c term, and I multiply them together, which is going to give us 25, so that's a times c. And then the b term on its own is just minus 26. So we look for two numbers that times to make 25 and add to make minus 26. They must both be negative. They must be minus 1 and minus 25. Okay, then because the a term is 5, I write 5r in both brackets, and I divide the whole thing by 5, and that will equal 0. We then put the numbers in that we worked out over there, which are minus 1 and minus 25, and then we divide one of these brackets by 5. We need to get rid of this factor on the bottom, and we can do that by dividing the right hand side by 5. So this gives us that r must equal 1/5 or r must equal 5. Now it does say clearly to find the value of r, so it's only one answer, and I'm looking at this part here and I'm thinking to myself, that needs to be positive because a circle's radius must be positive. So if r was equal to 1/5, like we found here, this would not work, because it would mean that the circle would have a negative radius, because 1/5 minus 2 is negative. So therefore r is equal to 5 is the correct and final and only answer. Okay, next question, and it is a culmination of lots of different topics here, but it does say that the area of the shaded segment is 200. Calculate the radius of the circle. So what I'm going to do is I'm going to create a sector, given this is a video about sectors, like so. Whoops, like that. And I'm going to use a circle theorem. And the circle theorem is that if you have this sort of arrowhead shape where all sides or all vertices touch the circumference, then the angle at the circumference is half the angle at the center. So that angle there is 150. It's a good start, that. And now we need to set up an equation, don't we? Because if I was to work out the angle of the segment, I would first want to work out the area of the segment. I would first want to work out the area of the whole sector, like so. And then I would want to take away the area of the triangle, which would be this part here. Okay, the darker green. So that's what I'm going to try and do. I'm going to work out the area of the sector first, and then take away the triangle. And all of that should equal 200. So 200 should be the area of the sector which is 150 over 360, times by the area of the whole circle, which would look like this. So that's the area of the sector. And then we're going to subtract the area of the triangle. Now we're going to use the area of a triangle formula, which is a half AB sine capital C. So it's going to look like R times by sine of 150. Okay, so just to reiterate, what we've done there is we found first the sector, which is, I should have used better colours. The sector is all of the yellow bit. So that is this thing here. And then what we're going to do is we're then going to take the triangle away. And if I do that, I'm left with just the shaded bit that was given in the question. That shaded bit there, that shaded bit is equal to 200. Okay, so now it's just all about solving. So first off, what we'll do is we'll do 150 divided by 360. That looks like it could simplify. 5 over 12. So 200 is equal to 5 over 12 pi times r squared minus sine of 150. What is that? I think that might be minus, it's a half. Times by the half here is going to give us a quarter, and then r times r is r squared. Next, I'm going to use a neat algebraic trick. I'm going to factorise out an r squared. So this term, the bit that came from the yellow, will be 5/12 pi. And this term that came from the blue will be just minus a quarter. I'm then going to divide by this bracket because this is multiplied by r squared. So I'm going to get 200 over 5/12 pi minus a quarter is equal to r squared. So to finish off, r is just the square root of 200 over 5/12 pi minus a quarter. And that way I could do it all just in one calculation, just like this. So 5/12 of pi minus 1/4, and then we just press equals, and it should give us our correct answer. So r is equal to 13.7. Brilliant. Okay, final question, and it's a tough one. We've got a diagram showing a sector of a circle, and we got told what the radius is. It's 6 plus x, and we know that on the other side it's also 6, it's like so. We know the angle's 50. It says the perimeter of the sector OBC is twice the perimeter of the triangle OAD. Find the value of x. So the perimeter of the sector, that's where we should start, the start of this equation. What's the perimeter of the sector? Well, we know, as we've been doing before, that the arc of the sector is the angle over 360 times by 2 pi r. So times by 2 pi, and then times by r, which is 6 plus x. Okay, so the perimeter therefore is this thing here, then added on. So far the arc that we've worked out here, this arc is just this bit. So the perimeter is also going to include this bit and this bit. And both of those two things are 6 plus x. So we need to add on 2 lots of 6 plus x, and that gives us our perimeter. So that's the blue bit done, and we know that's equal to 2 times, as this question says, the perimeter of the triangle. So the perimeter of the triangle is this distance here, which we know is the same as this distance here, because the question says they're both 6. And it's also this part here, which we're going to need to work out using the cosine rule. So AD is equal to, the cosine rule is b squared plus c squared minus 2bc cosine of capital A. So it's the two sides next to the angle, which are the b and the c. So they're both 6. So it's 6 squared plus 6 squared minus 2 times 6 times 6. Sorry, this is all, let me just rewrite the cosine rule properly. This is what the cosine rule is in your formula book. So we've got 6 squared plus 6 squared minus 2 times 6 times 6 times by cosine of the angle, which is 50. And that's all equal to AD squared. Okay, so let's go to our calculator to work out what this is. So it's 6 squared plus 6 squared minus 2 times 6 times 6 times cos of 50. Okay, so that gives me AD squared is equal to 25.7. So therefore AD is equal to the square root of that, which is 5.071. Okay, so now we're in a position to work out the overall perimeter of this triangle. So the perimeter is 6 plus 6 plus 501. Okay, great. So this is our equation now. We just need to solve it. Sounds simple enough. Okay, so let's do, what's the most efficient way of solving this equation? Well, there's lots of ways of doing it. I'll do the way which probably I think most people would do in an exam, and that's just to times out and just get values down. So that simplifies to 5 over 18 pi, but we need to times that through by 6 plus x. And when we multiply out this bracket, we're going to get 12 plus 2x. And we can actually work that out nice and simply by just doing 2 times 6 plus 6 plus 5.071. Okay, so that's 34.12. Right, I'm going to go the kind of factorising route, which avoids using the calculator as much, and it therefore also gets the most accurate answer. So I think it's the best thing to do, so I'm just going to do it, even though I don't think most people would actually do this in an exam. But anyway, we're timesing this by 6, and we get 5 over 3 pi. We then need to times this through by x, and that will just give us 5 over 18 pi times x. This 12 we can subtract over to that side. So just write plus 2x, and then take 12 away from that. That's nice and easy. That's just 22.142. Okay, now these two terms here have an x in. So I'm just going to take out a factor of x there, like so. Like that, and then what we're going to do is we're going to move this to that side, and we're going to obviously subtract it in order to do that. So it's 22.142 minus the 5 over 3 pi, and that gives us 16.906. And then finally we can just divide through by this factor. We can do that all on our calculator. So I think this is probably the most efficient way of doing this. Like so. Real nasty question, but hey ho. So we take that previous answer and we divide it by 5 over 18 times by pi. And then we add on 2. We get equals, and we get 5.885, which is to three significant figures, 5.89, and that is in centimetres. And that is job done. Hope you enjoyed that. See you in the next one. Bye for now.